Okay, hello everyone. I think we are live. Very happy to be here today. Melanie Mitchell is our guest. Before John introduces Melanie, I'm just going to say a few words about the Salon. The Learning Salon aspires to discuss contentions and bridges between biological and artificial learning. We hope to have people from various diverse disciplinary backgrounds join us and join in the discussion, ask their questions. So do not feel any hesitation to ask for a clarification. During the talk, we prefer to keep engagement to a minimum, just so that everyone gets the opportunity to listen to the talk without distraction. Brad and Kanaka in the chat will respond to you guys in terms of clarification questions you might ask during the talk. And if you have questions you would like to be voted by others and asked, click the Ask the Question button and then enter your questions and vote for other people's questions. And there's a poll today, and in this poll, if you just click below next to people, you can see that it asks about which discipline you belong to. This will really help us if you participate to understand what are the different disciplinary backgrounds. We are more than 70% into the year. And I know that a lot of people are very busy with the beginning of the new semester, but we're very happy to have you here. I'm Aida Mohamed-Nejad. I'm a senior researcher in reinforcement learning at Microsoft Research. And we have here as other hosts, Joshua Fogelstein and also John Krakauer, both professors at Hopkins University. And John will now introduce our guest, Melanie Mitchell. We're excited to hear her perspectives and discuss with her.
Hello, everybody. It's a great pleasure to be able to introduce my friend and colleague, Melanie Mitchell. We first met at the Santa Fe Institute, and I have been a fanboy ever since. Melanie is a professor of computer science at Portland State University and is now the Davis Professor of Complexity at Santa Fe Institute. Melanie is actually in Santa Fe right now. I had read Melanie before I met her, and I'm going to just plug two of her books, which I love. One is her book on complexity, which is a fantastic introduction to complexity science. And then this is the book that really led to her invitation, which is Artificial Intelligence, A Guide for Thinking Humans. It's the second book, which I highly recommend, by the way, that we'll be discussing today. And Melanie, thank you so much for being our third speaker at the Learning Salon. And we're very excited to hear what you have to say and to give you a hard time. All right.
Thank you, John. I'm really happy to be here. So I don't know if any of you got my slides to share.
Yep, I have your slides. I will share them now.
So I guess if anytime you want the slide to change, just say next slide and that should work.
Yeah, perfect. So when John announced this talk on Twitter, he said he was going to start with a question, and he asked, what is the meaning of meaning? And that generated so much discussion on Twitter for the last, several days that I thought I could just put up this slide and say, go at it, everyone. Because everyone has an opinion, a very strong opinion about this. But let me just, before kind of opening it up to everyone's view on AI and meaning, I'll say a few words of my own take and how I got to thinking about this issue. So next slide. Okay, so we all know that deep learning has revolutionized a lot of AI tasks, and we've seen its prowess in all of these different areas, and here I'm just listing a few of the things that deep learning is known for doing. And it's fantastic, it's amazing, but it has some limitations. And one of those limitations is that it tends to be somewhat unreliable. Okay, next. So many of you have probably seen this plot of the error rate at the ImageNet object recognition competition going down, 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 down that is better, better, better as networks get deeper and deeper and deeper. And that red dashed line is the so-called human level. I won't go into how that's measured, but I'll talk about that later if you're interested. And so this really gives the impression that neural networks have surpassed humans at image recognition. But of course, that's not true. And let me show you a few of the issues with the unreliability. So next. Here's one experiment where, all the ImageNet images were downloaded from the web. But the question is does learning image recognition from the web mean that image recognition is solved in real life? And in this experiment, some people outfitted a robot with a camera and had the robot move around a house, sort of photographing everyday objects that from just the way that a person might see it. And here's what happened next. They showed that if you train one of these neural networks, and here's a bunch of different neural networks and deep neural networks, if you train it on the images from the web and test on the images from the web, its accuracy of all of these networks are quite good, up in the 90% percentage point. But if you train on the web images and test on, I don't know, can you all see the slides, the bottom part of the slides? For some reason, I can't see them, but.
It's because of the
pictures.
The pictures of us, right?
Yeah.
I don't know how to get rid of those actually.
So can you all see the table, like the bottom of the table here?
We can't see the second row. We can see the first row, and we can see the top of the numbers, so we can imagine what the numbers are.
Yeah, so how do I get, okay, well, there we go.
Yeah.
That's better. This is a little harder to see, but you can see the second row now, that if you actually train on the web photos, the photos from the web, and test on what the robot's photos look like, the same objects, the accuracy plummets. So somehow the neural networks are learning something about recognizing photos from the web, but it's not holding up when you actually show it photos from this very different kind of collection. Okay, next. Okay, another group showed that if you take images that a deep neural network can recognize very well, like 99% confidence that this is a fire truck, and you Photoshop that fire truck in different poses next, it starts to recognize different kinds of objects. Like here, it thinks that this is a school bus, next. A fireboat, next. And a bobsled. So, one of my graduate students said that would actually make an awesome bobsled. But the question is, what are these networks actually perceiving in these images? It's something quite different from what we humans are perceiving. Okay, go next slide. Many people here will be familiar with these notion of adversarial examples, where a human can engineer some noise, like what we see in the middle row, middle column of each row, that's added to an image. And you can barely see this, but the noise is specially targeted to make the neural network think that the image is an ostrich. In every case, this noise added to the image, which is shown in the right-hand column, looks exactly the same to a human, but the neural net is very confident that it's an ostrich. So these kinds of adversarial attacks have been shown in many different domains. And what they demonstrate to me is that these machines are somehow perceiving or understanding this data in a very different way than what we humans are understanding. Okay, next. This has been shown with medical images. You can't really see this because the pictures of us are blocking it. but if you can take medical images and that of a lung x-ray that looks perfectly normal to a radiologist, but adversarially distorted so that the neural network that's doing the diagnosis thinks that it 100% has a lung disease, and vice versa. Okay, next. People have also shown that you can fool face recognition systems with these adversarial glasses frames. So for example, in the second column from the left, you can see one of the authors of the paper wearing some 3D printed glasses frames with a special pattern on them. It's a little bit hard to see in this slide, but they cause a neural network facial recognition system to be quite sure that that guy is Mila Jovovich, the actress, because they're targeted to do that. And so what are these neural networks actually seeing here? It's hard for us to tell because they're so, these very deep neural networks are hard to interpret, and they don't do a good job of explaining the decisions that they're making or what features they're really focusing on. Okay, next. This kind of thing has also been shown for image captioning that sometimes can make strange mistakes. Keep going, next slide. And next slide. You know, probably a lot of you have seen these kind of things. You can also adversarially attack these image captioning systems to target certain words in the image. Okay, next. This is all to kind of show you that these systems are unreliable. Okay, next. I'll talk about these both at once. So these two pictures just show that the state-of-the-art speech recognition systems have biases in that they are worse at Black people's speech and women's speech in terms of error or accuracy. Okay, next. Let's skip that. Next. Okay, here's an example from machine translation, which is fantastic. You know, it does a fantastic job, but this is one I tried with Google Translate. I gave it a little story about John, who was, and this is not the same John that's the host here, but a different John. He was displeased with his food and he stormed out of the restaurant without paying. I'm sure John would never do that, but the waitress yelled after him, "Hey, what about the bill?" She shrugged her shoulders and went back inside. And if you look on the right side, okay, next slide, I highlight the French. For any of you who speak French, it translates, "Hey, what about the bill?" into, "Hey, what about the projet de loi," which means kind of the legislative bill. So it's getting the wrong sense of bill there. And of course, these you know, Google Translate and other translation platforms are moving targets in the way that they improve themselves all the time. But they do make these kinds of weird mistakes that show that they really don't understand, in a sense, what the language is that they're dealing with. Okay, next. We've seen problems, of course, with autonomous cars that are trained on lots and lots of video of driving, but they sometimes can get mixed up by things that they haven't seen before, like salt lines on the road, which in advance of a big storm, which people tweeted was messing up Tesla's autopilot system, couldn't figure out where the lanes were. Next. And we've certainly seen a lot of examples of, for instance, Tesla autopilot not recognizing stopped vehicles on the road, like fire trucks, and crashing into them. Okay, next. And much more commonly, self-driving cars get into accidents that involve people rear-ending them, which is, of course, the person's fault. But the reason that people rear-end them is that these self-driving cars slam on the brakes unexpectedly because they perceive things as obstacles that no human would actually perceive as an obstacle. And the people are not expecting it. So somehow these machines are perceiving their environment, but understanding it in a way that's quite different from humans. Okay, next. Okay, and this is just an example of fooling a self-driving car vision system with stickers on a stop sign, which were targeted to make the machine learning system believe that this was a speed limit 80 sign, which is kind of scary. Next. But it actually worked. And so in all these different angles and distances of the stop sign, the machine's top class was usually speed limit 80, even just with these little stickers. Okay, next. We see this also with question answering. State-of-the-art question answering systems can do things like read a paragraph and answer a question about that paragraph correctly. I won't go through the whole details, but then it was shown that if you just add some irrelevant language to the paragraph, so that's in the next slide, so there's that irrelevant language, it changes its prediction. It changes its answers. Next. To Jeff Dean there. Okay, so what is it understanding? What is the understanding happening here? So that's one of those things I want to sort of get at. Okay, next. I think this is my last unreliable slide. I hope so, because I think I've gotten the point across. But this is an example where standard breakouts of Atari video game that DeepMind, the company that built AlphaGo, they also built reinforcement learning systems to play Breakout and other Atari video games. And it learned to play Breakout better than the human tester, way better. But another group said, okay, let's take the machine that is trained on standard Breakout and does extremely well, and just shift the paddle up by a couple of pixels. Can it still play? Okay, and it turns out that it can't play well at all on that given that very small change. It can't adapt to it because at least this version didn't have any understanding of the game the way we humans understand it. That there's a paddle, there's a ball, there's sort of this physics of the paddle hitting the ball to take out bricks. Okay, next. So the title of this talk came from this quote by the mathematician and philosopher Giancarlo Rota, who asked whether AI will ever crash the barrier of meaning. And to me, that barrier of meaning is the idea that AI systems, while they can perform very well a lot of the time, are brittle in this way that I've been explaining because they don't understand in the way that we humans do. Okay, next. Okay, you can skip this. Let's go. That just says what I just said. So the question that I want to pose is that to be reliable and robust in human domains, do AI systems actually need human-like understanding? Or, next, do they simply need more data and more network layers? So that's an open question, I think. I don't think we have the answer. And one problem is that this notion of understanding is not a sort of scientific term. We don't know what we mean when we talk about understanding. And that's because we don't understand our own intelligence very well. Okay, next. So just as an example, I want to talk about the notion of perceptual categories, which is what I think neural nets have, and concepts, which is what I think we humans and other animals have. And that's really what I think of as the basis of our understanding. Perceptual categories are kind of a way of dividing up one's sort of space, discriminative space, into different words like dog, cat, boat, etc. But concepts are much richer. So let me give an example. Next. So think of the concept of bridge. Okay, you might be able to show a neural network all these different pictures of bridges. you can't even see all of them, but yet you can still see their bridges. But to a human, the notion of bridge is much richer. Okay, next. We can easily extend our notion of what a bridge is to this weird object, which is a water bridge. There's a highway running underneath this river or this bay or whatever it is. And this thing that you're seeing is a bridge of water built over the highway rather than the other way around, a bridge, the highway built over water, which is what we usually see, and boats flowing through it. So we can understand that immediately, even though it looks very different than the other bridges we've seen. Okay, next. I see all these comments going by, but I apologize, I can't read them in real time, but hopefully we'll get into the discussion afterwards. We can also recognize bridge of ants, ants, this is something that ants do to cross from one surface to another by building a bridge with their bodies. Next. Or we can bridge our hands, or next. The bridge, we have the notion of the bridge of our nose. We know what that means. Next. The bridge of a song. Next, I hope, just kind of go through this fast. Keep going, because I'm just going to give a bunch of different examples of bridges. We have Joe Biden telling us he's the bridge to the next generation of leaders. And we all know immediately what that means, because we have this very more rich concept of what a bridge is. And so, and what makes it a concept, in my mind, is that we can extend it in this way. It's not just a perceptual category, it's a concept. Okay, next. Okay, these are just more bridges you can think about. You can keep going on and on. And so Hofstadter, who is a big proponent of analogies and big influence of mine, he was my PhD advisor, defined a concept as a package of analogies. And I think the bridge example kind of shows you where that idea comes from, because what we're doing when we extend this concept is we're making analogies. And he wrote a paper called Analogy is the Core of Cognition, which really pushed the fact that analogies underlies all of our abilities for conceptualization, abstraction, generality, transfer, etc. Okay, next. And here's another quote from Hofstadter and Sanders' fantastic book called Surfaces and Essences, which is all about analogy. Without concepts, there can be no thought, and without analogies, there can be no concepts. Okay, next. So I'm almost to the end here, but I wanted to mention this. There's a great blog post by Andrei Karpathy. So most of you in AI have probably heard of him, but those of you who not, he's a deep learning vision expert who is now the head of AI at Tesla. But back in when he was a grad student, he wrote a fantastic blog, and one post was about this photograph of Obama here that came from the White House then. And Karpathy asked, what would a computer need to understand this photograph? Okay, so next. Okay, and so I've just written a whole bunch of things that kind of people think about as the core components of human-like understanding. And I wonder if you can make the slide smaller so people can see all of it. Yeah, so there's all these different things that people have proposed, the idea of core knowledge, like intuitive physics, biology, psychology, notion of causal modeling, grounding of abstract ideas in physical metaphors, embodiment, maybe even consciousness. These are all things that come into sort of play when people are talking about understanding in psychology, cognitive science, and so on. So I think, it's interesting that Josh Tenenbaum often talks about the game engine in your head. So this is kind of the new, we've all seen all these metaphors for the brain. So all these neuroscientists know that, we have all these great technical metaphors for the brain, like phone exchanges and Turing machines, and now we have vector spaces, and Tenenbaum is pushing this idea that the brain is actually like a game engine, simulates physics and so on. Okay, so all of these things are possible components of human-like understanding, but we still are trying to put the whole big picture together. Next. And I just wanted to end by quoting Marvin Minsky, who wrote this back in 1980, that these so-called pre-scientific terms, including meaning and understanding, are technically too coarse to support powerful theories. You know, they're only the first step toward better concepts. And he said, the traditional ideas that we have are inadequate to this tremendously difficult enterprise, and this is still a formative period for ideas about mind. I think this is still true, and this is why I really believe that AI, in order to progress into sort of overcoming this barrier of meaning, really will involve humans and those of us in cog-sci, neuroscience, AI, etc., getting more insight into this tremendously difficult enterprise of understanding the nature of intelligence ourselves. So I'll stop there and open it up for any discussion.
So I have many questions.
So much Go at it.
I just want to say thank you, Melanie, for braving our salon and coming on. I just want to say that I am essentially in complete agreement with you, so that makes me boring. So I'm going to subject you.
Common adjective to describe you, John.
So I'm going to subject you to questioning from Ida and Josh, and I will be here to defend you if they get too mean. All right.
Ida, do you want to go first, or should I go first?
You should go first. Just for the people who might be sort of thinking about that last slide, we are, of course, aware of implications of Minsky in the Epstein trials, and this is not a validation of him. So I just wanted to say that. Go ahead, Josh.
Okay, thank you for pointing that out. So it's really, I think, a lot of really intriguing ideas that my sense is any of us in this field should probably think about a lot harder than we have and that we do. My question is, so my background is I have a PhD in neuroscience. I do a lot of work in machine learning. I think about how the brain works a lot. I think about writing down statistics, pattern recognition problems, optimization problems, Bayes' theorem. I never really think about meaning. It just doesn't come up. I don't know how to write it down in my equations. And so I wonder if you think that my kind, so to speak, is going to lose. Basically, are you really claiming that we're going to hit a barrier and we're not going to be able to get better at all? And the people who are able to wrestle with these ideas and make conceptual progress with this concept of meaning, whatever it may be, as pre-scientific as it is, they're the ones that are going to carry the day and make sure we don't have like the third AI winter, make sure that we get thinking AI that can solve our problems and is peaceful and trustworthy. Is that the claim you're making?
I think it depends on your problem. So the problem that you're trying to address. And what you just said kind of reminded me of back as an undergrad, I took a course in neuroscience. And they never mentioned once during the course that the brain is for thinking. They never mentioned anything about thinking during the course. It was all about cells and properties of these neurons and so on. But it was, it certainly, there were certainly important research questions that level of thinking, that level of understanding could deal with. But there's certain research questions that it can't, I think. And so I think it depends on what your questions are. So I think what I'm claiming is that might be controversial is that if we want AI to be trustworthy, as you say, if we want it to be robust, if we want it to work with us in our world, we have to have it do a better job of understanding. I don't think understanding is an all or nothing thing. I don't think you can say, yes, it understands or no, it doesn't understand. But what we have now is not going to solve big problems of collaboration with humans in the real world, at least some of those problems. You know, maybe you will be able to better understand certain research questions that you're looking at. Maybe it's sufficient. I don't really know sort of where meaning comes in, where it has to come in. And I think that was part of the big debate that we saw on Twitter. So I think that's, you know, it's an open question.
I have a slight follow-up question from one of the slides that you had this really beautiful picture of what you said was a water bridge.
Mm-hmm.
And the thing that was intriguing to me is when I saw that, I thought, oh, that's a tunnel. And then I wondered, who gets to be the arbiter of whether the thing has meaning? Because if it said tunnel, I think I would have said it was right and you would have said it's wrong.
That's funny. I never thought of it as a tunnel. But I don't know if I would say it's wrong. But you're right. Who gets to be the arbiter? And, you know, as we can say, humans don't agree on the meaning of everything.
Such as the word meaning.
Yeah, exactly. So you're right. And people often ask me, you know, what if AI doesn't understand in the way we humans do, but understands in a sort of different way, in its own way, mm-hmm. which is kind of a hard question to answer. But I would say in that case, we're going to have trouble working with it. We're going to have trouble trusting it to drive us around in autonomous cars or make decisions about our lives. And so we have to get a better sense of what we mean by understanding sort of how there's certainly a lot of things that we agree on, more things that we agree on than we would probably disagree on in terms of concepts. But AI needs to be responsive to us, since the purpose of creating it is to help us, not to create kind of alien intelligence. At least that's my purpose.
Fair enough. I want to hear what Ida has to say.
So thank you so much for your presentation. I don't know anyone in sort of, at least in my community of AI folks, who doesn't think that many deep learning works are unreliable. And even if you have a different random seed, you can't replicate them sometimes. And everybody agrees that there are challenges in image recognition in real life, that we need human-oriented AI. In fact, a lot of us are working towards that, the kind of working with the sort of with humans. We all show these gotcha critiques or gotcha images from papers that actually are from the AI field, of course, that you were showing also. The breakout also is another example. There is a lot of conversations about working towards intuitive physics, especially in the past 3 years. It's grown a lot, about using object files and schemata, which appears even in the title of one of new papers from the Benjio lab by his very talented student, Royal. The idea that you would need to sort of extract abstractions and generalizations that would go from one domain to another, or have causal models, and systems that do analogical reasoning and also are capable of transfer. These are literally topics of different sessions and workshops and papers in every ML conference and AI conference. So it seems like there is a collective acceptance of the things that you were saying. And although they don't put all of it under the umbrella of meaning, there is a lot of reverence for work from cognitive science, from psychology, from, again, object files, schemata, attention, etc. And there is a lot of acknowledgement of the failures and the ways forward, and they identify what are the steps forward. And quite frankly, in the past just 2 years alone, there's been so much advances in this particular field. And there was also at COGSI, Cognitive Science Conference, an entire workshop around intuitive physics. So what I'm trying to understand, and I think the bigger question, the bigger picture question that I have is, what would be added to these attempts? How can we take your way of capturing things under the umbrella of meaning? Would be something added to the approaches that people are taking? Would it basically do the same but accelerate it in that direction? Or are you suggesting that there is something fundamentally unavailable to the approaches that exist, which is also not just deep learning? There is also, theoretical, or there's other approaches. It's not all just deep learning. So I wonder, what do you think exactly is missing from the already existing attempts that are acknowledging the shortcomings you are identifying and seem to be moving towards the same goals that you're mentioning, as you can see in the sort of the papers and workshop titles of every ML conference, basically? I'd love to see what you think, what are the steps that your particular take on this adds to that, and how it would either accelerate or offer, hey, this is what your frameworks need to change towards. What is the eigen sort of direction for change?
Yeah, that's a great question, very involved. And I do, I think I have seen a lot of increased interest in these issues just in the last few years, I would say. When I first got into the field, AI which was like in the late 80s, early 90s, AI and cog-sci were much closer to each other than they are now, or at least than they have been. And I kind of see a cyclical thing where, AI kind of went off in a direction of more statistical learning, deep neural networks, learning from big data, throwing more and more computation at these problems, et cetera. And that was seen as kind of the approach to general intelligence. But when that seemed to kind of run into some problems, although not everybody has divorced themselves from that, more people started talking about causality, and there was even like DARPA created this challenge of common sense. Build a machine that has the common sense of an 18-month-old baby, right? And these things have been growing, and I think it's great. So I do think there is some effort in these areas, but I think that still AI is perhaps, there's a lot of people in AI and they have different opinions, but there could be more collaboration among people who think about intelligence in different ways, and people who are focusing still quite strongly on kind of statistical approaches with big data. And I've seen, AI is not a monolith. Somebody once described AI as an anarchy of methods, which I think is a good description of the field. There's nobody in charge saying we're going to do this year. But I do see, people saying, okay, to make progress in AI, we have to, scale up our GPUs. We have to improve the amount of computation. That's like the main thing people are saying a lot of the time, of how we're going to progress in AI. If you read like the NSF or DARPA or the White House kind of pushes towards AI institutes and so on, they're all like, how are we going to build this giant infrastructure that we need? As opposed to, how are we going to think more deeply about what intelligence is? So I'm not saying that people aren't working on these. I've been really inspired by people who are, but I'm not sure. I think the field could do more to think about this problem.
Awesome. Can I push you a bit more on that, maybe? Because I am 100% in agreement that the solution to general intelligence is not to throw more GPU at it or any kind of big data at it. Actually, I don't use the term big data pretty much ever in my work. And I haven't heard it from my immediate colleagues either. I want to ask, what exactly do you think, in which directions of the landscape of AI do we need to push or move in order for getting closer to the objective that you were describing? Is it different from what people are doing? Is it doing faster and more instead of throwing GPUs at things and comparing who gains 2% more over another, instead of seeing, does it generalize? Is it defining more tasks that are in the sort of multitasking domain, which people have been doing, including like, Chelsea Finn has a famous course on it at Stanford that's on YouTube and everybody can watch. I think that a lot of us are in agreement that more GPU is not the solution. A lot of my colleagues just go to the whiteboard and write equations all day to think whether they can find a provable way to solve the representation learning problem. But what do you think, which direction is it that you think is either lacking or should profoundly change? Do we need a qualitative change in one of the directions? Or is it a soft critique of, hey guys, you're doing 80% GPU-ology and then the rest of it is a little bit innovation, right? Is it just the proportions? Is that a soft critique? Or is it a harder critique that says, we need to completely rethink, for instance, the framework of reinforcement learning, or something is entirely wrong with all of the learning methods that exist, and we need to move it in a different direction?
Well, that's a hard question to answer, but let me say two things. One is the way, and I'm obviously not the only person who's saying this, but the way that kind of research is evaluated in machine learning in particular, I think is a problem for the understanding issue that I was talking about. So, as you say, we have these benchmark data sets, and people can publish papers that, they show their method did X% better than the state of the art on this benchmark data set, and therefore, hooray, we're done. But there's less work on trying to figure out what these machines have actually learned. And accuracy is one metric, but there's other metrics to thinking about how intelligent or, how much this system has learned what we're trying to teach it, that have to do with robustness and transferability and lots of different ways of kind of probing these systems that I don't see people doing. There's definitely people who are trying to push for that more, but I still see this kind of state-of-the-art benchmark chasing.
I see. So it's a kind of a ratio. It seems like less people are doing the interpretability of representations. What representations are we learning? Are these reliable for transfer? Which is something that a lot of our group actually is doing. That's why I guess. And I know that because maybe some more of a DeepMind approach is a little bit more familiar to the people in neuroscience. It might be the thing that comes closer to their mind. It might sort of not be as apparent, but I guess at every ML conference, you have a lot of papers that focus on that aspect. But you're totally right that the ratio is not the same. So am I correct in understanding that it's that what you're saying is we're putting too many eggs in the basket of benchmark chasing, and but you're not saying that every learning approach that we have right now in ML needs to be completely fundamentally changed?
I'll say I don't know, but let me add one other answer to your previous question. So my own work, one of my areas of work has been on analogy, sort of how to get machines to make analogies. And that's been a long time kind of people in symbolic AI have worked quite a bit on that area using various approaches. More recently, there's been kind of a flurry of work in deep learning on that. But it's become focused on benchmarks. So one of the things that I've seen lately is, people saying, okay, let's find a good domain for analogy making. One of the domains that people have been kind of focused on are these so-called Raven's progressive matrices, which is a kind of IQ test-like thing. And there's been a whole bunch of papers, and there's been these data sets of these automatically generated analogy problems. And then you apply whatever your deep learning method is to this, and you show, yes, I did even better than this last paper. And then the next paper that comes along says, oh, wait a minute, this whole data set is flawed because there's shortcuts that you can take without actually solving the real problem, right? So I think that this approach, this idea of analogy making is extremely important area that's somewhat understudied in AI. But the way to evaluate it, the way to figure out how are these machines working? By what mechanism are they making the analogies? Are they actually doing what we think they should be doing? That's really important. So I'd like to see more of that. And we're actually, I'll give a little advertisement. I'm collaborating with a couple of other people. We're having a symposium at the progl.ai Fall Symposium Series on conceptual abstraction and analogy making to talk about these very issues. And it's focusing both on sort of how people do this and also on how we get machines to do it.
I 100% agree that that is the way to go. Just to the point of symbolic AI, I genuinely don't think that that is the way to understand intelligence, and I'm just going to say that. And so I do believe that we need the sort of the learning approaches to get there. And I totally agree with you that we need representation learning approaches to look into robustness and transferability. And from what I'm understanding, based on what you're saying, is that the existing approaches could get there. They just need to focus on particular questions more.
I would like to see more focus on sort of the science of how these machines are doing what they do, rather than kind of the score they get on particular benchmarks.
Oh, absolutely. I think people who work on the interpretability of representations and the structure of representations that are learned or stored into external memory and retrieved, or structure of memories, like the sort of the either in eigen decomposition or other ways of figuring out what is the relational structure between certain memories or certain concepts. I think that people who are working in that direction would agree with you. We have 19 questions right now, and we are at around the time. I guess we have 6 more minutes until the time that usually we go towards questions. I want to see whether other panelists have any questions. John has been awfully quiet, but also I think his camera is frozen. I don't know if we can hear him.
Am I still frozen?
Your camera is frozen, but we can hear you perfectly. So I think that it's safe to continue. Oh.
Let me see if I can do it again. Does it work now?
It was frozen in a very flattering pose.
Oh yeah, I hate that. You know what? It's so interesting listening to the conversation, because it feels like a very slippery bar of soap, right? That you want to sort of point out a problem, which I think is a deep one for psychology, neuroscience, and AI. Meaning is difficult, right? And we have no idea in neuroscience either, right? So in other words, it's equally difficult. And then you can have people, and I've been noticing in the chat, saying, well, why can't we have a stab at it just as much as the philosophers, the psychologists, and the neuroscientists? And I think they should. And they may argue that they're just going to, through an evolutionary zigging and zagging, getting a sense of the problem, have just as likely to stumble upon the factor X that's missing as the scientists, the biologists. Right, so that's one sort of flavor you see here. People go, "What do you mean? We know we're not there yet, and we're just going to keep chipping away at the rock face, and we'll get it." Right, but I don't fully buy that, because I think even in neuroscience, forget about AI, meaning and human cognition are also somewhat downplayed, because we think that we can just find some principle in a mouse, and then we can just sort of find some scale invariant circuit property and quite easily extrapolate from that to some of the weird stuff that humans do, which is like a bridge of your nose and a bridge of ants, and so I think what we've got, regardless of what field we're in, the sort of animal model reductionism of neuroscience, or the let's start with classification in AI, that at some point each field will get to that point of meaning that is equally difficult for both fields, right? They're both in the same boat, actually, Melanie, right? And if you see it that way, they're just going to say, hooray for pluralism, just let's keep going, and the hard problem will fall in both fields. Right? That's the kind of reasonable counter argument that they'll make to you, right? But we all know that in order to get funded, in order to, OpenAI have AGI as our goal, and to get grants funded, we have to make premature extrapolations from where we are now to where we'll get to. So it seems to me, just to finish, that we've got this bilateral objection to you, which I don't share, which is, one, we'll get there in the end. It's just the hardest thing to reach, right? And Jeff Hinton and others have said that this is the hardest thing to get to. And other people go, there's no there. There's no such thing as meaning. Meaning is just rule following. Meaning is just performance. So in other words, you've got this two potential ways of objecting to you. And what I would say is, if you had to make a bet, and I'm going to put you on the spot here, would you give it over to the psychologists and the biologists and neuroscientists with the cells that they kept describing to you? Or would you just allow DeepMind and OpenAI and the others to keep on chipping away and bet on them? And actually, Josh actually said, who's going to win once, in a conversation we were having. Where would you put that? Or would you say it's going to be an SFI universal theory of intelligence that doesn't come from neuroscience or from engineers?
Oh boy, I hate that question. Well, we just got a grant here at SFI called Foundations of Intelligence in Natural and Artificial Systems, which we're going to try and produce this theory. But I don't think. Gosh, who would I give it to? I don't know. It's too hard a question. I don't think it's the right question. DeepMind and OpenAI have neuroscientists working there, and they have people who are doing actual neuroscience, and so does Microsoft probably, and all those companies. And it's not like it's. And as and here we have Josh who said he's a neuroscientist who only does machine learning. So I don't think it's like that so clear cut. I think the AI people, it's not a monolith, as we said, and some of them are interested in commercial applications, some of them are interested in science of intelligence. Some of them are just want to build machines that can play video games really well, or So I think the understanding part is only going to come from looking at the science, but that doesn't mean you can't build like really successful AI systems without understanding. People have already done that. The question is, what kind of systems? Can we have things like self-driving cars out there that work really well without the kind of understanding we have? And probably the answer is, well, only if we really limit the kinds of environments in which they can drive, because they can't deal with everything that we humans can do, because they don't have this like 20% of the problem which requires understanding. I don't know. That doesn't really answer your question, but it was too hard.
I think it's just I think for the sake of the questioners, it's just I've noticed there's just an oscillation between both cognitive neuroscience, and AI, recognizing that there's this barrier of meaning and there's this extra thing with all your lovely examples that we're not there yet, and I think that's fine. Everyone should have a go at it. Versus another strain which just doesn't think it's a problem. Right. And I think I am very much on the side of saying it's a problem, but I'm very agnostic as to who's going to solve it and bring insights towards it. What irritates me immensely is when people actually think that what you're talking about is a pseudo problem, right? And I think that is dangerous if it gets sort of explained away, right? Rather than being central. So that's just the point that I would make. Which type of objection are we making here? And I think I am convinced by you that it is a problem, but I'm open to whoever wants to solve it.
I think Ida objects.
Okay.
I just want to have like one addition. First of all, we should probably add a section, what annoys John, and then like
That'll be a very long section.
yeah. But just with regards to what you were saying earlier, Melanie, in response to John's first comment, I think I'd like to just mention that it's not just that neuroscience is helping AI to build something, or we as neuroscientists are sort of helping AI or artificial general intelligence or self-driving cars. That's like a very small fraction of what actually is going on, and it's been going on historically. I mean, historically, the neural networks were meant to help us understand, in fact, human cognition better. That's how I encountered them. That's when I learned about them, when I was reading, whether I was reading about that, the Dartmouth conference where neural networks were invented and there were a bunch of people there, whether I was reading the sort of the early cybernetics and cognitive science sort of masterminds, whether I was moving to Princeton and I knew the work that people had done there, people like John Cohen, Randy O'Reilly, Ken Norman, Jay McLellan, the kind of the tasks, uses that they had for neural networks was in fact to understand mechanisms of memory better. It was a way to formalize our verbal theories of what some memory or some cognitive process was, and better understand it, make actual commitments to a particular theory versus another by formalizing it, by building a neural network. So I think that we shouldn't forget that, yes, currently there's a lot of noise and clutter in the space, but at the same time, there was a very foundational rule for using models to understand human cognition better and to clarify our theories. And I think that that still has enormous value, even in our sort of collective move towards understanding the kinds of problems that you and others have raised, or everybody at ML conferences raised, and you're nicely putting them under the umbrella of barrier of meaning. But I think it's useful to commit to particular formalization of concepts, even if we're talking about meaning, just so that we can actually have the opportunity to say what's lacking from one formalization and what's lacking from the other, just moving forward. And I think something that was very useful in what you were saying in our conversation is, let's analyze the structure of the learned representations and see if they have the kinds of properties that would allow, for instance, transfer, for instance, analogy. And not just focus on, did it perform well on this arbitrary benchmark that we set? I think that that's quite valuable, and that's something that some people are doing, and they should do a lot more.
Okay, so let me have a look here.
Well, John's looking. I want to answer your question, John, because you asked who's going to lose. I'm going to.
Oh.
I want to pick some fights here because you guys have been very political and polite, and that's boring. We should fight. So I'm going to just go on a limb and say the deep minds and the open AIs that are investing hundreds of millions of dollars in building a bigger network are going to lose, and they're going to lose hard. I think it's both. It's not going to work, and it's arguably morally not okay. It's not democratic. You have to have $1 billion investment to build the best model. And that means you need $1 billion to like publish the best paper and to get accepted. Because like what Melanie was saying, you need to get epsilon better. And the way to get epsilon better is have a bigger model with more data. And also every time you train it, you burn down a small forest. And there's enough forest burning. You don't need more forest burning down. So I think they're going to lose on intellectual grounds and moral grounds. And I think they're going to lose soon. And there's some evidence that they're losing already. There's far fewer jobs for that kind of thing listed these days than there were 6 months ago. I think there's a lot of other people who are going to lose too. The philosophers, as smart as they are, I think they're going down hard too. You need, I think, to win this fight, you need to be kind of doing the stuff that Ida is doing. Really, like you need to be both thinking hard about what is the thing we're trying to solve, understanding the theory, understanding the biology, and understanding the machines. That's a really hard thing that takes collaborative efforts that I think you can do at a place like Santa Fe. You can do at a place like where IDA is. And there's certain academic places that you can do it. But the rat race of the hype of, we're going to get AGI soon. I don't want AGI. Humans are stupid. I fall for magic tricks all the time. I want something much better than me. I can't do matrix multiplications, right? Why are we so great? We can do a subset of things, but we can do those things. I don't want machines to do those things. I want machines to do stuff I can't do.
Well, they already can, right? I mean, they can do matrix multiplications. And
I know, and it's awesome. And we should.
So you don't think there's any value in AI for? You think that the AI researchers are not going to lead to any new insights about meaning or understanding or anything?
I'm not sure. I know that, when people doing AI for medical images to try to like identify whatever, you showed a couple things. I don't remember exactly what they were. Doctors can do that now. I want them to do better than doctors, not worse than the doctors or approximately as good. I want them to solve problems that we're not solving. I want them also to trim my hedges. How close are we to that? That should be an easy problem. How much meaning is required to trim my hedges? I'd say very, very little. And we're decades away from that. And we're pretty close to being able to replace radiologists.
Well, what if you have the thing is trimming, the robot is trimming your hedges, and a dog comes along and starts barking at it and gets in the way of the hedge trimmer?
Yeah, you should get an AI dog too, like a robot dog. Fight the hedge trimmer.
I guess the question is, you can think about these kind of domains as very narrow. How much meaning do you need to trim hedges, right? It's very narrow. It's a very, but the problem is in the real world, like unexpected things happen. You can't just put, a boundary around this one task and say, this is all it needs to do, and then let it loose in the real world, because strange things might happen that it would have to deal with.
Maybe, but that also feels to me like a religious belief. Like, maybe not. Maybe you can build a machine hedge trimmer. Maybe there's just not enough money invested in it. If NVIDIA and IBM were going to make billions of dollars trimming hedges, I guarantee you we'd have a lot better hedge trimmers right now. Turns out they make billions of dollars with deep learning.
I think that's an argument you could make about autonomous cars, that we are putting billions of dollars into autonomous cars. And how hard is driving? It's not that hard, right? Teenagers can do it. But these machines are not able to deal with this very open-ended problem where lots of unexpected stuff can happen because they don't have this kind of understanding or common sense that humans have.
Or maybe they're smart and we're all crappy drivers, and really we should get all of us off the road, let them all drive, and they wouldn't have any accidents.
Ida, go ahead. Unmute yourself.
So first of all, no to that last. Secondly, Theriol, who is together, we organize a workshop at NeurIPS that I'm chairing called Biological and Artificial Reinforcement Learning. She works at DeepMind, and she works with Nando, and she was just saying that the depiction of what DeepMind does by Jovo is unfair, and she's saying that it's good to realize these companies are big and have several people working on different projects. Looking at publications, you can see there are a variety of topics being addressed in these companies rather than just making bigger models. And she adds a smiley face. So she's very kindly reminding us not to sort of this cartoonish representation of particular one or the other particular approach might be an unfair characterization of what some of our colleagues are doing on the same topics. And I encourage anyone who's at NeurIPS to come to our workshop and see that there are like a lot of different approaches to biologically plausible machine learning and sort of bridges between biological and artificial learning. I think we should go to our.
I just wanted to make I just wanted to say one thing about that, which I think it is important. I was just watching an interview with Matt Botvinnik. It's really interesting, right, that a lot of people in cognitive neuroscience, who take a Marian perspective, are functionalists, right? And if you're a functionalist, at least a default functionalist, that you believe that you can do computation and algorithmic cognition with a different substrate, which I don't think that only neurons and biological tissue can be intelligent. I don't think that that should be a position we should take. And if you are, then you should really consider DeepMind and OpenAI and other such places as places that are going to help us as cognitive scientists with the functionalist claim that you can get cognition computation algorithmically in a substrate agnostic way, right? And I do believe that. So I don't think it's that you have to be working on biological tissue rather than non-biological tissue to get at cognitive operations that are close to the human suite. I think that's why I'm saying that I believe that it may just, the functionalists may win at the non-biological departments. But whether you're a functionalist or whether you believe it has to be neural tissue, you do have to worry about this self-referential, reflective capacity that humans in particular have. And you can just, whether you call that meaning or not, it is an extra cognitive component that we have to worry about, okay? And that doesn't mean worrying about it implies that you don't believe in computational algorithmic solutions to intelligence that don't require neural tissue. Extremely important to realize that. And it may well be DeepMind and OpenAI and other such places that do the functionalist work better than the biology departments. It may well be true, right? It just may well be true. Okay.
Given that I'm a functionalist too, the +1 to that.
Yeah.
So should we go
I am a huge fan of DeepMind.
Just like, yes, I agree that functionalism means that we can abstract away from the biological level. And for those of you who are not familiar with the term, functionalism in the philosophy of mind is this idea that you don't need the exact same biological substrate to have a particular function. The famous example that was used in philosophical texts was pain and C fiber. And some people thought, okay, every time you have pain, we are talking about an operation that relies on C fibers, but octopus, for instance, doesn't have C fibers. Does that mean that octopus cannot have pain? And from there are a lot of other examples that go on and on in the philosophy of mind. And a very nice article at the different levels of explanation also talks about situations where non-functionalist approaches would fail because they might be at a wrong level of representation. The famous example is that of money. If you want to explain money entirely in the domain of physics, you will have to have a large subset of different kinds of materials, of coins and credit cards, etc., that have not even existed, and keep adding them. And you will never be able to derive causal properties of money, for instance, in an economical system from the physical level. So the type money does not have a type at the physical level. You need that type at a higher level of explanation in order to understand the way that it has the causal effect in the world. So that's some background for those of you who are not maybe familiar with the philosophy of mind side of it. And a lot of us, of course, when we build algorithms, we're hoping that we are capturing at the right level of explanation. And I think that Melanie's highlighting of another level of explanation that we might be losing sight of if we focus on certain charts and sort of benchmark chasing approaches is very well taken, in spite of the fact that it seems like we might have a passionate discussion here. It's definitely very well taken that there is a level of goal setting where we define our objective functions for where we want to go. It seems like we should define it at a level that is actually going to advance appropriately. Okay, Joe, do you want to read questions? I've talked a lot, I feel like.
Sure, I'm just going through the questions and seeing who that asked the question is willing to come on screen.
Okay, so.
So if you have asked a question and you're willing to say it out loud, that I think we prefer that you ask it rather than we ask it. So I'm just going to.
Audience, would you like to please type in the chat area if you would like to ask your questions out loud from anyone who has had any questions posted? People who posted 20 questions. Would any of you want to come up on stage? Please identify yourself in the chat area. I'm not seeing anyone, so let's read one and give them time. The one with the most votes is asking, is understanding detectable from behavior performance? can there be meaning or understanding without consciousness? This is by Daniel Final, and it has 6 votes.
So this is something I've struggled with a lot. Can understanding, like, how do we decide if a system is understanding? Well, it's really hard because we don't know what even we mean by understanding exactly. We can look at a system probably and decide that it's not understanding. You know, lots of people have been posting things about GPT-3, right? This big language model that OpenAI put out that can generate very realistic sounding text, but it has certain, it outputs certain things that make it very clear that it is not understanding in the way that we humans usually use the word. But how do we decide? Is it, you know, how do I decide that any of you are understanding? It's really, all I have is your, you know, what I can perceive of what you say. I can watch you, I can look at your body language, I can, you know, ask you questions, I can probe you, but it's all behavior-based. There's nothing, I can't look inside your brain except, you know, maybe we have sort of beginning of tools that can help do that. And that's, I think, what was the root of the Turing test. You know, Turing basically said, how do we know if something is intelligent? And he basically threw up his hands and said, you know, there's nothing we can do except probe its behavior. Okay, so the Turing test, obviously, the way that people have implemented it hasn't been very useful because it's too easy to pass the Turing test. People are too willing to assign intentionality to the machine or whatever entity they're conversing with. But I think that, you know, that the idea of the Turing test is still probably the best way to think about machine understanding and machine intelligence. I'll probably get attacked for this, but I think a properly done Turing test is really the only tool that we really have. So I'll let you say what you think.
So I think we have 2 people coming in. I think Jonathan Flower. Okay, there he is. So Jonathan, ask your question.
So my question generally emerges from a pragmatist philosophical background. Specifically for Dewey, the only way we can pose the question of understanding either of images or of objects broadly is through implication in culture or a universe of discourse, which seems to have been missing in the conversation thus far. So my question is, do you or anyone else view this as a fundamental problem in the ways that we're asking the question of meaning and understanding, specifically insofar as pragmatism takes understanding as a social process?
I don't think you can have an entity that understanding that happens like in a brain in a vat, which is what most of AI is these days, right? I think that intelligence in general is a social thing. It probably evolved because of its utility in social groups. So, and you know, as you say, a meaning is a social construct in some sense, but it's, you know, I don't know, it's hard to say, you know, all of our mind, we're all humans at least, you know, are extremely similar in terms of structures of our brains, say, compared to other animal species. And so it's a lot easier for us to share meaning. We share experience, so we share meaning. So, but yes, it's a social construct, but it's kind of driven by evolution. So I don't know if that's what, yeah, so Ida has a comment there.
So that's a great question. I just want to highlight a couple of approaches that I think, so the sort of normative and discourse-oriented approach to meaning, I agree with you that it's kind of missing. And one thing that I want to add that might be relevant here, is that work that combines NLP and reinforcement learning, such as some of the work that we're doing, where learning of objects and learning of sort of the words and concepts in the sense that is used in NLP that are highly correlated with the object that you're learning. Combining the two of them is something that we have a group that we are working on, and some people there, like Harm Fansayan, is doing a lot more work on that. He's at the MSR in Montreal. And I want to also highlight some research that came out of DeepMind a couple of years ago, where they had agents that gradually, they needed to cooperate, and they started to create a system of communicating with each other in order to optimize their performance. So I think that you're totally right that when we are talking about the sort of the rising of meaning from a discursive, cooperative context of multiple agents, I think, or norms that are in language like the ones that are studied in NLP, putting together with the kind of ways that we interact with objects, I think we will get a lot further, because a lot of the times, the ways that we are conceptualizing a lot of things is because we want to share those concepts at the end of the day. And it's not just because of the structure of our brain, it's because of the conventions we come up with to make our cooperation easier. And that's, I think that work that was done at DeepMind was sort of towards that direction. And there's also work on machine theory of mind and other kinds of sort of cooperative AI, Katja Hoffman's group at MSR doing in the Xbox framework. So I think that there's a lot of attempts towards this socially embedded idea of AI and meaning that are very worth noting. And I do believe that we need a lot more of that. I agree with you.
And I would just add, actually, Jonathan, that it's interesting, in Daniel Dennett's last book, he very much makes, I think, the point that you're making, which is that he believes that culture plus cortical plasticity leads to the special forms of human cognition. He actually really feels like it's a cultural feedback loop that trains the brain to its cognitive capacities that people feel humans have. And then there's a book, I don't know if you're familiar with, Cecilia Hayes, she's at Oxford, called Cognitive Gadgets, where she also makes this claim that it's culture and its objects that feed back in that then lead to these cognitive phenomena that you will not find if you don't look at this loop between the culture and the cognitive gadgets and the brain. So in other words, there are people pushing this view. Actually, I think my brother believes this too, that we forget about cultural objects training us. And that's why we have the advantage we have. I don't know quite where I stand on it. I think, Cecilia's book is really interesting on this issue. So I think it doesn't get enough play. I think you're, and I don't know how much cultural training is happening at places like OpenAI and DeepMind. I actually don't know the answer. Maybe someone can say something about that.
I would just add that Andy Clark, a philosopher of mind, has written quite a bit about how intelligence is sort of goes beyond just like the brain and the body, but out into the environment and the artifacts that we interact with in the world. And I would recommend his books also.
So for those of you who might not know in the audience, Andy Clark is a philosopher. His famous extended mind, extended cognition approach had this example of Otto, who's not good at memory, and he has a notebook, and he writes things in his notebook, and that's serving as an external memory. But together with that device, together with this sort of cognitive technology, then he's he resembles, his behavior resembles a person who actually has memory. So he argues that the limit of the mind doesn't end inside the brain. Sometimes it's extended to some cognitive gadgets, and not cognitive gadgets is the word of Cecilia Hayes. Some tools and technologies that we would be using to extend our cognition. Jonathan, did you want to follow up?
You're on mute.
So that leads to the question of whether or not we should engage in a process of enculturation for machine learning or artificial intelligence, right? If we want, say, self-driving cars to become better drivers, then we should immerse them in the, say, cultural and social context of driving in the specific country or the specific situation where they're engaged in. So the question that follows from it, if the social is something that doesn't get enough play in, say, the development of artificial intelligence and machine learning, should we engage in aggressive processes of socialization of machine learning and artificial intelligence such that it can take the meanings that are circulating within society and then engage in ways that are more productive for the aims that the intelligence is going to be put to?
Yeah, can I comment on that? That's a great question. And you know, people in AI talk about this quite a bit, and they talk about sort of culture aligning with human values is a thing that people say, and imbuing sort of moral values in machines. But one of the big problems with this is, you know, given like the examples that I showed, machines still don't even have the scaffolding of concepts that we need in order to get to the point where we can imbue them with values, because values are complicated concepts, right? So we have to be able to give machines the ability to have concepts before we can give them values. That's my view.
You know, a short example of that is, I don't know who said it, maybe you know, Melanie, that I'll believe that we can start getting the machines to align with us when it doesn't just win at Go, but it cares that it won, right? And I don't think to Melanie's point, we have any idea how to make the computer care that it won rather than winning. And if it doesn't care if it won, how can it ever get into our culture? I just don't know how that would work at the moment, you know.
What would you need, Ron, for it to care?
I'm just saying that one of the ways that you're part of a culture is that you actually, you know, you care that, you know, The Godfather 2 was better than The Godfather 1, or that you care, you know, you have to have a cultural exchange where you actually care about, you know, our values, right? And it's just, we have no idea how to make AlphaGo go, yes, I won. We haven't the slightest idea.
Or even better, damn, I did.
or a related point is, if we want the machine to pretend that it couldn't have won. So my cousin did this when he was learning how to play chess. He intentionally, once he got better at my grandfather, he started losing on purpose because my grandfather was old and he didn't want him to feel bad, and they were still having fun. Machines aren't going to do that anytime soon.
Yes, they are. I mean, deception is not a very challenging thing to do. I think once you have a capacity, you can pretend like you don't have it. And a lot of people are asking also in the chat, and honestly, I'm not sure. Are we moving towards dualism? Is that what's happening? What do you guys need for this care? I want to understand, like, maybe short answer, just like, I want to know, what is it? Is it a soul? Is it like, what do you need? Is it something that you think that computational models can never have? Sometimes I worry that we are not intentionally, but unintentionally might be opening the back door for dualism.
Caring, Ida, is you worrying about dualism.
You don't know if I'm sentient. You know, I could be an AI that is.
But you're worrying about dualism.
You're acting like you were.
I'm not saying that I don't understand what caring means. That's not what I'm saying. Let's not strawman my.
But anyway, Blake's here dying to say something, I think. So we should thank you, Jonathan. Right.
Yes, indeed, I am. Thank you, John. And I mean, it touches on this caring point. So the thing is, I think that in these discussions, people often conflate two separate issues. So there is the question of, how do you get a machine, or how do we understand how neural circuits solve some of the incredibly complicated tasks that they successfully solve and exhibit some of the incredibly complicated behaviors that they do for neural circuits? And in the question of AI, how can we get a machine to exhibit those same behaviors? This is a very challenging problem. It's a monumentally challenging problem. And I think that the vast majority of AI researchers would agree that we're not anywhere near there yet. And I'd even say that a large number of AI researchers would agree with Melanie's perspective that we need to build in more human-like mechanisms into AI in order to achieve that. Then there's the separate question of whether there is some additional problem of meaning. So let's say theoretically that we had an AI that didn't exhibit any of the pathological things that Melanie highlighted in her talks. It did what we do. It sees the same kind of things that we do. It behaves the same kind of ways that we behave. And in general, it passes some kind of total Turing test, right? Where it is behaviorally indistinguishable from a human being. Some people want to say that there's still a problem of meaning there. And I think that the issue is that when these two problems get conflated, people like me, we start to get our backs up, because I'm one of those nasty people that John mentioned who thinks that the philosophical problem of meaning effectively dissolves. And if, in fact, you have a system that is behaviorally indistinguishable from a human being, it understands, according to any basic, sensible use of the word understand. Likewise with care. What does it mean for someone to care about the result of a game? It implies a whole host of behavioral repertoires. There's not some special magical thing in our brain that is caring. It is a series of programs that ultimately lead to particular behaviors in particular circumstances. You stomp your feet, you throw your drink down, you upend the board. God damn it. And it's not that caring is just these behaviors, but it is whatever it is that allows us to exhibit these behaviors. And so I think that what I would like to see in discussions like this is ideally a recognition that that first problem is a really interesting and really hard one. And it's ultimately what I viewed Melanie's talk as being about. Here are all these ways in which AI clearly doesn't match us, and arguably, to get it to match us better, we should think about what's actually going on in our brains and try to implement some of that in the AI. And also think about, and I really like the point, by the way, Melanie, about the benchmark chasing. Also think about moving away from benchmark chasing and moving towards more robust ways of measuring AI behavior. But then I hear someone like John say, but there's this additional there's a hard problem there that we have yet to solve. And I don't see that there's any hard problem there. And I suspect that this is where we end up parting ways. But if we could just focus on that first problem, I think eventually, yes, we would chip away at it, and we would, if our society doesn't collapse, eventually solve it. And the problem of meaning in AI would dissolve.
Wait a second, Blake, you started off by saying, yes, that there is a really hard problem, which is getting machines to sort of do all the things that we do. And then you said, no, there isn't a hard problem.
There's not a hard problem in terms of if you were to get a machine. So sorry, there is a hard problem, but it is not the hard problem of where is the meaning. If you were to get a machine to actually do all these things that we do, then it would understand. It would have the meaning. There would be no problem of where is the meaning.
I think, Blake, correct me if I'm wrong, are you assuming that we can get there without meaning, and then saying, then when we do, we'll have demonstrated that you don't need meaning?
No, I'm saying that there is no such thing as getting meaning. I think that there is getting a machine to exhibit all these behaviors, and once a machine exhibits all these behaviors, that is a machine that understands the meaning. But
right, so basically we have no disagreement, because basically you're just being. I mean, if I had a machine and I showed it 3 New Yorker cartoons and it laughed out loud at 3 New Yorker cartoons, I would say that AI gets it, and I would say it gets the meaning of the joke. And I have no problem. All that Melanie and I are saying is that if you want to get to a computer that laughs at a New Yorker joke, you better understand what meaning is.
Okay, so hold on, let's back up there. It's that last sentence that I object to.
I know, but it's a non-objection.
No, it's not a non-objection, because what I'm saying is that in order to get there, we need to think about the structure of representations, but the way we need to think about them is not by asking, how do you inject meaning into a representation? The question is, how do you get representations that allow you to exhibit these behaviors?
But the interesting representations that matter are the representations that are used as representations, which means that they have content, and you use them causally because of their content. And content containing representations is just another way of saying meaning.
What's the difference between a content-containing representation and a non-content containing representation?
Well, for example, the CPG in your spinal cord, which generates leg movements, has no representation of a leg in it. Whereas if I say to you, Blake, think of the word facetious, imagine it in your head, and count how many vowels it has. If you can imagine the word facetious in your head and count the number of vowels in it, you're working on a content-based representation, whereas your CPG can drive your leg and there's no leg representation anywhere in it. Those are the two different kinds.
No, but the CPG, ultimately, when you say it doesn't have a leg representation, that's because all it can do is drive this one pattern over and over again. It can't do anything other than that.
You just asked me for two kinds of representation, one with content and then the other, and I just gave it to you.
No. You've defined for me one set of representations that have very rich content and another set of representations which have very weak content. The CPG has content. Its content is where in the oscillatory cycle your current leg movements are. That's it. That's the content. And so, like, there is no such thing as representations with content and representations without content. All representations carry information about something. By definition, that is what a representation is. And when you talk about a representation with content, what you're doing is you're trying to fool us into thinking that there's some fundamental difference between one form of representations and another. But the only thing that differs between these representations is their complexity and the complexity of the behaviors that they can subserve.
A gradation for a difference, it just gets us down to when is a few grains of sand a pile of sand. You can get the discrete out of the continuous. And if you're just going to say, John, there are weak representations and strong ones, it's just another way of saying that they're different to each other in some way.
Well, okay, so look here, we agree partially in the following way. Like, I agree that we would say that certain forms of representations that don't represent a lot of information or successfully give us the ability to do very complex behaviors are not a very sophisticated form of understanding, but they're still a form of understanding. Let's also talk with caring, right? I would argue that RL agents have a weak form of caring. They don't want to do things that punish them, and they do want to do things that reward them in a very weak sense of it. And there is an actual caring there. It's just that the caring is not the sort of rich caring that we have, because we're using a much more sophisticated form of representing value.
I don't think you're disagreeing with each other.
No, we're not.
I mean, gradations, everything, thinking of these terms in black and white, like thinking of meaning or caring or consciousness or what have you in black and white, it's not. There's a continuum, but continuums can matter quite a lot. That it's not to say that.
I agree. So let me just I should cap off before taking up more time. I think the reason that this distinction between a continuum and a hard cap on there being content or not matters is it comes back to this comment that John made about just sort of plugging away at the problem. I would argue that we can plug away at the problem because there is no qualitative shift. There is no moment where we now arrive at meaning. And so as long as we just keep plugging away at the problem and we just keep determining systems that are better and better at exhibiting complex behaviors, and in neuroscience, we keep doing more and more, we will eventually get an answer that satisfies us.
But there can be a continuum and there can be a phase shift, right? Just because there's a continuum doesn't mean there aren't things that are different in kind. And I'm not actually taking a strong argument on either side. It's just that there's a continuum doesn't mean there's no qualitative real distinction on which side of a phase you're on.
Yeah, I mean, I half agree with you, but I should let things go now. I just want to say it was a great talk. Thank you very much, Melanie.
Thank you.
And I was thank you.
Yeah, to Blake's point, we should be careful that qualitative thing doesn't move into the domain of the sort of dualist mist or something, because I care. All right. Melanie, do you want to say something on that, or should we go to the next question?
Yeah, let's go to the next one, because I think we definitely talked about that a lot.
So I don't know if anybody's volunteering to come on the stage. Please just write something in the chat if you would like to be on stage. So the next one with the highest votes is by Zach Pitko. Did wonderful things at the Neuromatch Academy. So thank you, Zach, for being here, and thank you for your great work at NMA. Oh, somebody's on stage. Oh, that's
Brad.
Hi, Brad.
Hi, how you doing?
So Zach is asking, is understanding detectable from behavior/performance? Can there be meaning? Oh, I'm reading, sorry, the last question I read. He asks, a system that has meaning should generalize better. But what if there's another way of generalizing better? Take learning system 1 and 2. Number 1 answers questions about meaning better, but number 2 generalizes better on tasks we care about. When would you prefer number 1?
Sorry, number 1 does what?
So his idea is that there are different paths to having generalization and transfer. And if one of them is through meaning, and one is another way, some other way of achieving that. And that other way is such that it helps us generalize across different tasks, but doesn't have any notion of meaning. And he's asking whether you would prefer 1 or 2. And I guess I would add the question, do you think that there is the possibility of having a system that could do transfer without meaning?
Okay, so my answer to the first one is I can't answer that, because my answer to the second one is no. I don't think you can have generalization in the way we think of, human-like generalization without meaning in some sense. So that kind of hypothetical is a little too hard to answer, because it just doesn't make sense to me.
That's what I thought. That's why I added my extra question to their question. So Zach, to your question, I guess the answer would be that Melanie's position is there is no such thing as your system 2, which generalizes better on tasks without meaning. Okay.
I certainly can't prove it, but it's an intuition.
That's right. So the next one is from Jonathan Flowers, and I think he did ask these questions. So I guess we can move on to the next question by Brad, and he's on stage.
Hey, great talk. Thank you very much.
Thank you.
This is a topic that we've already touched on, so I don't know if there's more to say on it, but it regards the sort of trap of being in these empirical benchmarks cycling around. Do you conceive of a different way for AI to progress without specific benchmarks? Because they have been a very powerful driver of at least certain aspects of, development and research, comparison between different approaches. So what are potentially some good alternatives?
Yeah, this is a hard question, because benchmarks, right? So machines get better and better on these benchmarks, but then there's always some traps there, which is that they're getting better, but not for the right reason. And any data set that you want to kind of single out and say, here's a benchmark, machines are eventually going to learn to game it. That's just the way it is. I mean, and so I think that having big benchmarks maybe that people compete on is just the wrong way to make progress. And it also focuses so much on the kind of the score, like what is this number? What is your performance on this benchmark, as opposed to by what mechanisms is your system actually learning and what has it learned? So I actually think that these benchmarks have not necessarily been a plus in driving research in this area. What alternative to do? I think we have to maybe have, obviously have to have some kind of training, some data that people use to test their systems on, but maybe it has to be a lot more diverse. It has to be more open-ended rather than a kind of closed, fixed benchmark. Some places like the Allen Institute for AI has a big open web page where you can test their systems on your own data, which makes it a lot easier to figure out sort of how good they are and what they're doing. So I like that idea. I don't see why everything has to be made into this kind of competition. Research has to constantly be a competition for whose system does the best on some external sort of benchmark or criterion. But more, I think we just need ways to understand better how these systems are working. I don't think I have an answer to this. I wish I did. But I think there has to be a more diverse set of evaluations than what we have now.
I think I agree with you entirely, Melanie. I think a lot of other disciplines have wrestled with this idea, and they've come up with lots of ideas that I think are much better. So, for example, I think it's the X-ray crystallography community. They have a new benchmark every year. So you can't overfit it for years and years and years because it's always a new one. And I was actually fighting about this with Jeremiah Sulam earlier today. He's in my department. He's a brilliant kind of sparse modeling, convolutional, hierarchical, deep guy. And so my point there was, in medicine, when you want to know whether something works better than something else, you do a randomized control trial. You pre-register your analysis. You state your hypothesis, and you don't have the data in advance, and then you check. And that is so far from the way that most benchmarks in machine learning currently work. There is a workshop, I think in NeurIPS this year, on like reproducible or things like this, where people are trying to get a better experimental test bed. But people have figured out how to test hypotheses in the world about which things are working and which things are doing better. And the machine learning community has mostly ignored it. And I think at our peril, because there's lots of hard work that went into thinking about it, and they're really good ideas, and we can just adopt them.
I mean, it happens a lot in neuroscience as well, where a task is originally designed to test a capacity, like Francois Chollet has talked about, and then what happens is the task takes on a life of its own and becomes the phenomenon of interest rather than a indirect measure of the capacity that it's actually meant to be testing. And so I think it's Francois Chollet has written that we should go back to capacities rather than to tasks. And that's difficult because even in neuroscience psychology, what a task is really difficult, right? But I think in his article, Ida, correct me if I'm wrong, I think he talks about finding a capacity testing way of doing things rather than can you play cricket, can you play a video game, because there's more likelihood that there's going to be a multiplicity of ways that you can look good from 30,000 feet, just like, AlphaGo didn't play Go the way Lee Sedol played it, but if you were watching from above, minus that incredible move that it made, you wouldn't know. So maybe you're less likely to be fooled the more general the capacity you test rather than a particular task. But that's not, it's easier said than done.
Well, one of the problems with most machine learning systems right now is they need so much training for any task that they do, rather than, so humans, so think of this like Raven's progressive matrix thing, which, is an intelligence test. And I'm not going to say whether it's a good test of intelligence or not, but it is a test that they give kids and so on. But in machine learning, people have said, okay, we want machines to do this test, so we're going to train them on hundreds of thousands of examples of these problems and then see how well they do on the test set. As opposed to saying, here's an intelligence test. I'm not going to train you at all. I'm not going to allow you any training. Now go take this test. That's more of a capacity. And I think that's what Francois Chollet is proposing with his set of what he calls the abstraction reasoning corpus. And I think that's a better way to go, but it's much, much harder.
I think that, the key problem is that these tests and benchmarks are predictable, right? And so what you need is a way to generate a system that creates essentially unpredictable benchmarks, right? And that could be like a committee, that comes up with new benchmarks every year. as you suggested, Josh. Simon had a good point, though, that the machine learning community has done at least some things right in terms of having private testing data sets in some of their competitions. But I think that even given a private testing set, like on Kaggle, for example, you still have there's still a degree of overfitting to that problem space. Right?
Well, it's because with these machines, most of the testing sets are looking for what you might call interpolation rather than extrapolation. They're in the same distribution as the training. They don't change the distribution, and therefore they don't actually test generality very well.
I just want to add to that. So for those who are not familiar, I put a link to the paper by Francois Cholet on the measure of intelligence that John referred to and folks talked about. He talks about skills that would transfer across different abstractions. So he suggests this sort of set of environments that are created synthetically in order to have certain kinds of abstractions. To be fair, those sets of environments have come to critique for various reasons. I think Melanie earlier in her discussion, she mentioned about these critiques, like there could be some truths to them or there are particular similarities. I also included a paper called Scattering Compositional Learner that approaches this idea of progressive Ravens matrices that Ravens progressive matrices that I think that's one of the papers that Melanie was referring earlier for those who are interested.
I want to ask one more quick. Yeah, we're out of time actually, so I'm going to bail out and go ahead and let Simon talk.
Yeah, so I guess about benchmarks, I actually feel like benchmarks are a pretty good thing in machine learning that actually would be useful in a lot of other fields. Because I think like there is this problem that people overfit particular benchmarks, but when that happens, people just build new benchmarks. So like if you understand the weaknesses of the system, then you can build a benchmark that specifically focuses on those weaknesses. And so I'm wondering, like, whether if we think of benchmark design as kind of like an open loop thing where there's interaction between the researchers and the benchmark designers and the machine learning systems, whether it still has all of the problems that people have raised.
I think I agree with you that they have pros and cons. I mean, obviously, the ImageNet and other benchmarks have demonstrated capacities and have led to capacities that we didn't have in advance. I would just say that I still think there's a relatively limited amount of careful thought. Like, for example, Melanie was just talking about the difference between interpolation and extrapolation. Like if I were to design a neuroscience experiment, I would have a really clear idea of where is the convex hull of all of my data and where might extrapolation be. And we could design benchmarks in theory to assess the extent to which our AI algorithms are interpolating purely or they're adequately extrapolating. But that's not in the conceptual repertoire of any benchmark I'm aware of. Maybe there's a few new ones. The Core 50 is a nice one. There's some other ones that are kind of coming online. So I think the perspective on benchmarks is maturing. I just think it's behind other fields currently and could catch up.
Yeah, so then is the idea that we just need better benchmarks, or are there things that you actually can't benchmark that we need to be we need to be measuring in some other way?
Well, I think benchmarks, if we're talking about collections of examples of a problem, and yes, we need those, and machines should be able to we should be able to test our machines on them. We have to talk about how do you measure success? Is it just like accuracy versus more robustness kinds of measures? That's one question. Another one is how much training do you allow? Do you just allow unlimited training? And that's kind of what Cholet was trying to get at in his papers. That defeats the whole purpose of using these as evaluations. So we're using them in two ways. We're using them, number one, for training the systems, and number two, for evaluating the systems. And we probably shouldn't be using the same benchmark for training and for evaluation.
Yeah, I mean, I agree with that, but I think like in machine learning, there's recently been like an emphasis on understanding what algorithms do out of distribution. So you train on one data set and then you test on another data set. And this is like something that people are doing now. And we realize that like there are some failures of today's machine learning models when you benchmark them in that way. But it's still a benchmark, and it's something it's a benchmark that people came up with because they realized that the existing methods have these kinds of limitations. And hopefully by pushing those numbers higher, we can eventually end up with a system that actually generalizes to those new situations in ways that current systems don't.
Yeah, I mean, that's definitely an improvement. And I think it's the way that has to go. We have to be able to show that these things can extrapolate. Now, it's not, when we talk about this notion of distribution, the distribution of data, that's a kind of a fuzzy notion. We talk about it as if it's a rigorous thing, but it's actually quite fuzzy, And I think that's something that we need to make more sense of. What we mean by that.
Or just plot the learning curve, right? I mean, to both of your points, we have a benchmark already. Maybe it's fine, but let's just plot the learning curve rather than the final number after burning down 5 forests. Compare the learning curves instead of that final number. That's also kind of to Chalet's point, right? Where we want to look at the speed with which we can learn rather than just the overall end of performance for a particular fixed task.
Right. So that might be, but that's a different measure than most machine learning people care about.
And it's not a scalar; it's a whole curve. So it's more nuanced and complicated. There's going to be some algorithms that go up faster but saturate earlier, other algorithms that go up slower but eventually overcome. And those are two different, interesting operating points that we want to understand both of them better.
Yeah, I mean, I think like most people in machine learning would like agree with this, that we want to know both like what algorithms are best with limited data and how well you can do if you have all the data in the world and then take your model and try to apply it to some other task. Like these are like things that people think about. And I guess it just seems like a lot of people, when they apply machine learning systems in the real world, what they care about is what is the best possible performance we can get, which is usually performance that you get by training on all the data and not just some of the data. So I think like it's kind of related to machine learning being both a practical field and a research area.
Sure, but if you want to say, how good are neural networks at solving abstraction problems? And so you say, okay, well, I'm going to test them on Raven's progressive matrices, because that's a good measure of abstraction. So let me train them on 20,000 Raven's progressive matrices. Then you've suddenly defeated the whole point. I think that's kind of what I'm trying to get at.
So basically what Melanie's asking for is do well on the test without any training, Simon.
Well, train on whatever you want, but don't train on the test that you're going to.
Don't train on that, right? And the thing is I have a question for you. Is there a way to, I mean, when you do Raven's progressive matrices task, the training you do is life, actually, right? So what is the equivalent in the machine learning community of a vague lifelike training that bears no relationship to the test you're about to get? Could you tell me what that is?
Continual learning, lifelong learning, these are literally fields in ML that they have their own workshops.
Right. But as of today, what would you do before you did the Raven's progressive matrices task right now that bore no relationship to that test, just like a human or a child? What would your task be before you gave them?
Right, that's a really good question. I don't know, but I think one approach might be that people actually do is like it's kind of like GPT-3. It's like self-supervised learning. You watch a video and you try to predict the next frame, right? And you learn sort of what representations you can get from that, and then you take your Raven's progressive matrix and translate it into that, like, representation space. People do that kind of thing. It's not super successful yet, but maybe it will be. But that's the kind of thing, I mentioned earlier this thing that DARPA is trying to do with their Foundations of Machine Learning program, where they're trying to get the common sense of an 18-month-old baby. And what their evaluation metric, they're kind of trying to mimic the developmental stages. So what they want to do is give these machines like the kinds of psychological tests you would give a baby to see if it, if it knows that when an object is occluded, that it's still there. I forgot what that's called. These kinds of things. And they want machines to go through these developmental stages. So the question is, how do you train it? Well, you train sort of the same way you train a baby learns. You let it explore an environment, and you have some theory, like maybe all of learning is auto-encoding, and then you run it on the test. So that's, I think that's a valid way to think about this kind of thing.
I mean, shouldn't we expect that we need to give these models a lot more data than humans have, because they haven't had a chance to evolve in the natural environment in the same way that humans have? And there's all of this information encoded on our genomes that are not going to be in these machine learning models.
Right, but one wants to have a theory of what that content would have to be, right? And it wouldn't be able to bear a relationship to the test you're going to do. So that's, I think, what Melanie said. What would it be? I agree with you that they have humans might have an unfair advantage, but we just would like you to tell us, well, what is the content that you want them to have that will allow them to pass the test without training to it? What's the theory?
Are you asking me?
Either Simon or you. And we can't just say, I mean, you're right that they have to have,
you have to have a theory,
but it'd be nice to know. Yeah, what is it?
Let's have a theory. I don't know what the right theory is, but I know that you have to have one, and you have to have a theory of what the priors are, or the intrinsic biases that the system has. And people don't really know. I mean, that's part of investigating this whole thing.
Yeah, I mean, I think the challenge is not finding the right data to train on, because we can just train on all the data. The challenge is finding something that we know is not in the data that we trained on. So like, for example, with GPT-3, OpenAI is basically just training on an enormous amount of text that's collected from the internet. And so there is like a lot of knowledge in there, but for any particular thing that you feed into that model, you don't know how much of what's coming out is just regurgitation of the training data versus the model generalizing, or the model actually being able to learn new things from the text that you provided to it. And I don't really know how to solve that problem, but I agree. Like the problem is you can't curate the size of data set that you need to come up with to train these machine learning models. So how do you come up with something new that you know isn't in it? And I don't know how to solve that problem.
Well, go figure it out, man. You got time. All right, Ida, you wanted Jonathan to come back on?
Brad was recommending, based on the conversations that were happening in the chat, Brad was recommending to have Jonathan back on. I just want to read one more question before we do that. This is by Jonathan Rowski, another Jonathan. And he says, Hofstadter also wrote an essay called Waking Up from the Boolean Dream, where he argued for having both symbolic levels and sub-symbolic dynamics in cognitive systems. How can we integrate the extensive linguistic, semantic, symbolic analysis of meaning and composition in AI instead of proceeding from the sub-symbolic dynamics?
Boy, that is the question. Yeah, I don't know. I don't know the answer to that. I mean, I have my own systems that are trying to do that I'm working on. But I think, again, that's something that we need we need insight from other fields that study intelligence, that think about those kinds of things. And I've been very influenced by like results in psychophysics that talk about sort of the different ways attention is used at different stages of perception and things like that. And I think there's a lot of cognitive science out there that will help us think about that. I don't know if anybody else has any comments. I know we've been going on here for 2 hours now, according to my computer. If that's a...
We'll finish with Jonathan here. Yes.
So Brad, did you want me to speak to the question of learning? Because that's at least from my philosophical perspective, that's a kind of a broad one. If you want an intelligence to perform in a particular way, you need to have it learn socially from other intelligences that perform in these ways so that it can learn the particular habits that are necessary to be applied in novel situations, right? So if we wanted a machine to say do a particular kind of task really, really well, we would train it on the rudiments of that task and then provide a novel situation where it could take up the history of its training and apply it within that situation. The analogy I gave in the chat would be like AlphaGo learning from its different kinds of victories and then applying the lessons learned from its victories in other novel competitive situations where it understood the rules, but it could take its experience of winning and applying it elsewhere. Another example I gave was, training a quadruped machine in the same way that a cat learns to walk, right? So these things, so essentially one of the things that I think we're missing is that learning, training, being able to apply the results of experience in novel situations is always a kind of social interaction, right? Or an interaction with an environment. Things don't learn in a vacuum. Even the most simple organisms don't learn in a vacuum. And to treat machines as if they can learn in a vacuum, I think is a fundamental mistake, right? But to be fair, I don't think we have the technology that would allow a machine to apply what it has learned in experience in a novel situation. I think that's kind of a hard limit we're running up against.
Yeah, I thought you had some really good points about, we can discuss like the fact that when humans are confronted with a novel situation or some case in which they can't successfully generalize, we have fallback options that we use to sort of figure out what the problem space is and then approach that problem from a different direction, right? And the question is there some sort of fundamental essence of human problem solving there, or is it just that we have learned, how to respond to novel situations?
I don't think there's a fundamental essence of human problem solving there. The thing that might be unique to humans is the social situation in which we engage in that problem solving. But all kinds of organisms do that all the time. My cat does it when she tries to get to my food, right? She has to determine the appropriate way to jump from the chair to the sofa to the table without me noticing so she can eat whatever I've cooked. Organisms do this all the time. It's how do we enable machines to do this, right? And I think the problem there is, broadly put, technological, because I don't think we have yet the technology to allow a machine to interact with an environment in a way that it can take up its previous experiences and apply them to novel situations over and over and over again in the same way that my cat might do, because all of her attempts to eat my food are just novel applications of the kinds of ways that she's learned to hunt mice in this case, right? So her avoiding my gaze and sneaking around are the same kinds of habits she would do to catch a mouse, except she's trying to avoid me keeping her from eating my food. So these are the kinds of things that if we want machines to do things novelly, we have to give them, or we have to provide a capacity for them to do it. And I don't think we have yet the technology to do that, except on like really small scales, or scales where are scales fundamentally distinct from what we're looking for.
I would just say to that, Jonathan, that you're sort of oscillating between sort of making a recycling claim for your cat. In other words, it basically recycled innate mouse hunting to hunt your food. Whereas, I mean, if you look at invention and novelty, in other words, if you look at generation after generation after generation of chimpanzees that have been studied by Jane Goodall, they're not inventing new things. They're living in a pretty similar way in the last 5, 6, 7 generations. Whereas we're constantly inventing brand new things. If humans are stranded on desert islands, they invent things. So novelty and invention are not equally distributed across the animal kingdom. I mean, the point has been made that in the last 200 years, children of the next generation have no idea how to use the toys of the previous generation. They're changing so fast that whereas, you know, seen one bonobo, you've seen them all. So there is something about invention and flexibility that has just gone stratospheric, a phase transition, as Josh said. So I'm not sure that we have to decide whether you want a computer to be innovative the way we are or innovative the way your cat is. And I think those are very, very different. And I think computers are more like cats.
I actually don't disagree with you. And the degree to which a given organism will be innovative within its environment is a degree to which, is based in the way that the organism is organized, right? So my cat doesn't drive a car because she has no need to. She can probably outrun me if given the chance. I would need a mechanical aid to do so. So she has no need to engage in a particular kind of innovative activity to expand her capacity in that way. Just as if a machine could do the kinds of things that organisms do, right? It could do them at speeds that would be radically faster than most biological organisms, right? Given its computational capacity and so on and so forth. So the conclusions it would reach and the development of its experience would be light years ahead of us. So its innovation would look radically different than anything that we would have in a kind of biological analog, in the same way that the chimpanzee's innovation is different from my cat's innovation, is different from my own innovation, is different from the innovation of pigeons, hawks, and other animals that have adapted to human environments. So my statement here is that we need to think about the unique ways that AI and machine learning will adapt to their own unique environments and not, say, imprison them within the confines of human adaptation. Or if we're going to do that, we need to do so for a specific task, and then they become tools and not specific, consciousness, in the same way that a horse might become a tool. But that there's other things that go along with that.
Yeah, just to comment briefly on that, one of the thoughts that struck me is, that we keep coming back to this idea of challenging AIs with problems that have definitive solutions, right? And so that's really where, another point of departure from the way that humans interact with things is that we don't just solve problems that are in front of us, we also generate new things. And so I guess the question is, is there a whole aspect of that we're missing? And are models like GPT-3, actually tapping into that in a usefully generative fashion? Or is it kind of a sort of, recursive generativeness that doesn't really advance out of the pool of training that it's received? And I don't think there's a great answer to that we're going to come up with in the next 5 minutes, of course, but it's just
Melanie, do you think there'll be an invention test?
Say that again.
Do you think there'll be an invention test? An innovation test?
Yeah, there already are. I know there's like in the genetic algorithms community, there's a prize for machine inventions. I don't know if it's a test exactly, but yeah, I think that's part of, one of the issues with machine learning is most machine learning systems are discriminative, they're not generative. People are starting to look at generative models much more extensively now, but we're much better at training discriminative than generative models, and generativeness is a really important part of, I think, testing and understanding.
Well, listen, this is wonderful. I think we've gone on for a record time, Melanie, because you've broken the record. I actually am going to have to go. Josh, Ida, you're welcome to continue hosting, but I'm going to get into trouble if I don't go. Thank you so much, Brad, Jonathan, obviously you, Melanie. I hope it was worth it, and all the
That
other
was great.
people that asked questions. And thank you very much. And this is recorded, and the questions are available, right, Josh?
Yep. Yeah. Anybody can log into what's this thing called? Crowdcast whenever and watch it again. It's also on YouTube.
All right. Hugs to everybody.
Okay. Thanks everybody for
Ciao.
joining. See you next.
Bye.
Bye.
Thank you, Melanie. Bye.
Thank you, Melanie.